Hi class, I'm going to believe you already went over the notes or you watched the video lesson. So let's do example 1. It says, find the pH of the unknown solution to determine if it is acidic or basic. And we only have the concentration. Remember, if it's in brackets, it's concentration. So let's write our pH equation. So pH is equal to the negative log of the hydrogen ion concentration. And this one is very simple. We just substitute pH equals negative logarithm of have 0.045. Notice how this one is not using scientific notation because this number is rather large in comparison to the other ones we talked about. And then what's next is just plug it in into the calculator. Let's go. Negative log. Remember, on yours, you should not have to type the 10 for the base because the standard base for log is 10. So you can just get away with log like it's over here. So 0.045. Press enter. And our pH is 1.346, so we're going to round to 1.35. pH equals 1.35. Now this is a very low number. It is way beyond or under 7, meaning solution is acidic. That is the answer. Whoa. There you go. It's a little better. Let's work on example 2. Let me use a different purple. There you go. It says, Angelica is helping out her mom by cleaning the kitchen and she saw a container with no label. The only piece of information he has, somehow, is the concentration of hydrogen ion, right? 1.3 times 10 to the negative 10 molar. Find the pH and use the scale to determine what kind of cleaning product Angelica has. So let's write the concentration. Hydrogen ion concentration is, even though it doesn't say it's hydrogen ion, we're going to assume because the problem didn't say, so we assume this is it. 1.3 times 10 to the negative 10 molar. And we use our pH equation. pH equals negative log hydrogen ion concentration. pH is equal to the negative log of 1.3 times 10 to the negative 10, close parentheses. Let's get our calculator. Negative log of 1.3 instead of times 10. Remember, I was typing on the base, so base 10. Now we write our number, our concentration, 1.3. Instead of times 10, we use the double E function. And then negative 10. One thing I want to point out, don't confuse the negative with the minus. This is a mathematical operation, and this one will give a negative sign. Okay, so if you use this one, it might just mess it up. So don't confuse it. And then enter. So the pH is 9.88. We're going to round to 9.9. pH 9.9. Now let's see on the scale. So at 9 we have egg white. I don't think it's an egg white. So bleach. So it's probably some diluted version of bleach. Pretty close, 9.9. You're right. Solution or cleaning product is, parentheses, probably bleach. And that is the answer. Now let's do the final one. Find the concentration. Notice how in this one we needed to find pH, but now we need to find the concentration. Don't worry, I'm going to teach you how. So find the hydrogen ion concentration in Essentia water. It's not giving any other information, but the picture, we can see very clearly that the pH is 9.5 or higher. We're going to pretend the pH, or we're going to assume pH is 9.5. So it has to be at least 9.5. Now remember how Ms. De La Peña taught us this about logs, where if you notice, the B for us is always 10. So B equals 10. The Y was the concentration, or in this case the H plus. And X was the pH, because if you see it over here on this one, let's compare log by equals x to log 10 concentration equals pH. So the X was our answer, that was the pH. Now if you apply this, you would have log 10 H plus equals pH, which is the equation for pH. Now let me move my camera a little bit. There you go. And it's over here. Now let's rewrite this one in this form. B to the X equals Y. So instead of B, we write 10. Instead of the X, we write the pH. And instead of the Y, we write equals hydrogen ion concentration. This is almost correct, but for us, we have a negative on our equation for pH. Or if you use this one, you can see the negative sign. So you add a negative. And there you have it. To find the hydrogen ion concentration, you need 10 raised to the negative pH as an exponent. So I'm going to write it over here before I move my camera. Hydrogen ion concentration is equal to 10 to the negative pH. I'm going to move my camera again. There you go. And let's solve it. Let's substitute. Hydrogen ion concentration is equal to 10 to the negative. We have the pH, which is 9.5. And let's mark on it. If you notice, like in my case, I have the 10 to the X where the log is. Yours is probably the opposite. You probably have log, and then if you look for I guess in a different color, you'll see 10 to the X. So pick 10 to the X. The way you should do it, the way you're gonna do it probably is second, you press log, and it's gonna give you 10 to the X. I have to only press it because my control will give me log. So my regular key will just give me 10 to the X. So 10 to the X. You can see 10 raised to an exponent. And don't forget the negative sign. It is very important. So negative 9.5. Press enter. So 3.16 times 10 to the negative 10. So let's write it. H plus 3.16 times 10 to the negative 10 molar. So if you buy essential water, you're going to have at least this hydrogen ion concentration in your water. So remember, to find concentration from pH, use this equation, which is concentration of hydrogen ion equals 10 raised to the negative pH. This is the exponent. This is part of the assignment. So if you get it incorrectly, no, I'm kidding. So I was going to say if you get it incorrectly, I'm going to know you didn't watch this video, but I'm not going to say that. So just try your best. Make sure you write this one down because I did not write it on the notes. This is a present for those who watched the entire videos. That's it. Bye, guys.